Okay, we're going to find the volume by rotating this region about the x-axis. We have the square root of x minus 1, and y is equal to 0, and x is equal to 5. Well, when we rotate it about the x-axis, we will get a solid like this. Well, if you are just talking about the area, we can put down a vertical rectangle for this. And you see, the width is dx, and then the height is dy. If you rotate it, you actually get a disk. So we can use the disk method for this, right? Remember, the volume of a disk is pi times radius squared times the thickness of the disk. So have a look here. The volume of this disk is going to be pi times the radius, which is the y squared, and then times the thickness, which is dx. This right here is just what we call the differential volume, namely a small change in the volume. Well, we want to add up everybody. To do that, we integrate. And we are in the x world, so pay attention to the x value. We are going from 1 to 5. 1 to 5, and that will give you the volume for this, right? However, of course, the y is not allowed in the x world, but we know y is equal to that. So just put that back right here. And I'll just set out the integral for you guys. You should be able to work this out on your own, or maybe use a calculator, depends on the direction of the question. But this is it. This integral will calculate this volume right here. Okay, we are going to find the volume generated by rotating the region bounded by this curve about the x-axis. So here we go. First, let me give you guys a picture. Right here, we have the x to a third power, which is like this, right? And then we have y is equal to x, which looks like this. This is the 45 diagonal line, of course, 45-degree diagonal line like that. Well, we just want x to be greater or equal to 0, so we care about this region here, okay? That's all. And if you set them equal to each other, you will see that when x is 0, they will of course intersect each other. And this is when x is equal to 1. How do we do it? Well, again, x cubed, make it equal to x. And what you should do is do not divide both sides by x. That's technically dividing by 0, no good. Move this to the other side, you get x cubed minus x is equal to 0. Factor things out. Factor out the x squared minus 1 equal to 0, and x minus 1, x plus 1 equals 0. So you see, the three intersections are at 0, 1, and negative 1, right? So that's the quick way to do it. That's the way to do it, I guess. Anyway, we are going to take this region and rotate it about the x-axis. So this is what we are going to get. We will have a cone on our side. So imagine that we have this right here, okay? So I will just do this one in black. So we have this right here, right? This is the one on the top. When y is equal to x, you have this portion, and when you rotate it, you get this top part first. And then pay attention to that x to the third power is actually on the bottom. And when we take this portion and rotate it about the x-axis, that's the missing part. So I try to subtract, and let's see, we will get this, and then like that. Somewhat like this, okay? And this is for y equals x to a third power, and this is when y is equal to x, like that. Now, of course, we'll do the disk method for this one and also for this one, and we'll just subtract them. And when you do the subtraction, it's called the washer method because we have the missing part in the middle, right? So have a look. The volume for this right here. You can do the disk method, and it's just like this, right? You do this right here. You use dx for the thickness, and the radius is just the y. So the volume is equal to, let me just write this down right here for you guys. The total volume is equal to, here is integral going from 0 to 1. The x value right here is 1, right? And then pi is pi, of course, and then the radius square. The radius is y, and y is the same as x. So we have the x, and you square that, and you have the dx, like this. This gives you the volume of actually this cone right here. Now for this part, you minus the integral going from 0 to 1. And you can, of course, put the insides together, but I think it's easier to see what's going on if I write it as two separate integrals. Anyway, for this one, again, we pretty much do the same thing. We have the same exact idea as that one. So you have the dx, and this right here is the y, but y is x to the third power, so you just have pi times y is x to the third power, so just make sure you enter x to the third power here, and then you square that, and then you have the dx, like this. So that's pretty much it. If you have to do this by hand, of course, just work it out x to the sixth power, and then do it by hand. Yep, but I will leave that to you guys, because the setup is the most important part. If you don't know how to focus, if you don't know how to set this up, there's no reason to continue, because if a wrong setup, of course, it's wrong. And focus on setup, that's where we'll spend energy for this section here. Okay, here we're going to find the volume generated by rotating a region bounded by this and that, and we are going to do it rotating about the y-axis. So here we go. First, let me just give you guys a picture of the region. Notice that we have x is equal to y squared, so it's just a sideways parabola. It's not so bad here. And secondly, we have the x is equal to 2y. This right here, if you would like, can just divide both sides by 2. So you just get y is equal to 1/2 x. Anyway, it's just going to be a line, and then you have a slope 1/2. So it's going to be something like this, right? So that's what we have. And of course, the region is this right here, and we are going to rotate it about the y-axis like that. And it's a good idea to find out where they intersect. So you see here and here, well, this is x is equal to that, and likewise this is x equal to that. That means I have to put this and that equal to each other. When we have y squared equals 2y, do not divide both sides by y. That's divided by 0. Not so good. So y squared, move that to the other side. This is much better. And factor out the y minus 2 is equal to 0. That means y is equal to 0, y is equal to 2. Okay? So right here, y is 0, and right there, y is equal to 2 for that point of intersection. And of course, you can also find the corresponding x value if necessary, but it's actually not necessary. Because we'll do the following. We're rotating this about the y-axis. So we're looking for the right minus left. So which one is on the right? Of course, you can just use your right hand and then just approach it, the curve, you see. First, we hit the line. So this right here is actually the one on the right. So we'll focus on this right here, okay? We'll take this piece and rotate it about the y-axis. So we actually will get a cone that looks like this, right? So this is the line rotated about the y-axis. And I'll just draw you guys this right here, right? Just a quick sketch for that. And then we have to minus, well, take this curve, rotate about the y-axis. So you see this right here is that curve, and then I'll rotate it about the y-axis, do the mirror image, and then do this on the top. So that's pretty much the quick sketch for this right here. So you have the big thing and then minus the hole in the middle, that's all. All right, so now here is the volume. For this one right here, well, we'll use the disk method. Just make horizontal cuts, and we get a disk right here. And have a look. Radius is from here to here. That's precisely our x. And this right here is nicely equal to dy, because it's just a small change in the y values. So for this one, I'll just put this down right here for you guys. We will have the integral. We have dy, all right? So you have to pay attention to the y values. We go from 0 to 2. And remember, it's pi r squared times the thickness. So we have pi times r, which is the x. That's the radius x right here. And for the first one, remember the blue one is what? This is the line. This is x equals 2y. So I will put the 2y right here. And then square that, and we are in the y world. So just like that. Secondly, for this one, same thing, right? So you have the disk right here. And you see this is the dy, and this is the x. And for this one, the curve is the one in black, which is x equals y squared. And I will just have to subtract integral from 0 to 2. Pi is pi. X is y squared, put the y squared right here. And don't forget to square that again. This is because of the function is y squared, and the square is because of the pi times radius squared. All right, and then we have the dy. And that is it. This right here will give you the volume of the solid. So you have the whole thing minus the part in the middle. Okay, we're going to find the volume generated by rotating the region bounded by this and that about the line y is equal to 1. So here we go. Let's look at a picture first. So, of course, we are graphing y is equal to x squared, and that's our good old parabola. So I will just give you guys a picture right here, like this. And the second picture is when x is equal to y squared, and that's the sideways version of the parabola, and that's going to look like this, right? So this is the region that we are talking about, and we also know that it's pretty easy to see they cross each other at 0, 0, and in fact, they also cross each other at 1, 1. You can just solve the equations, and I'll leave that to you guys, right? It's not so bad for this one. And in fact, we are going to rotate this region about y is equal to 1. So be really careful with this, right? It can be tricky sometimes. So we'll rotate it right here, okay? All right, I will give you guys two pictures as usual. First, look at the bottom portion. When you rotate it, that's going to be the outer part, right? Like that. And we will have to subtract the middle part. But let me just draw this for you guys first. Well, I will first do this, yeah? And then I'll do the mirror image, like so. And then at the end right here, I will do this. And here is y is equal to 1. And here is the x-axis. And here I have my y-axis, right? So just look at it this way and all that stuff. Okay, we can use this method to find out the volume of this right here. And then we will just have to subtract. Well, the blue portion you rotate, and you end up with this right here, and then this right here, and then the bottom will look like this right here, right? And again, this right here is when y is equal to 1, and again, x-axis, and then the y-axis. So that's about all. Now, volume. Integrals, of course. Have a look here. It's really tricky for this one. Be really careful. First, if you like, you can go ahead and draw your disk. And this time, because my opening is over there, just because the way I draw the 3D picture, I will also draw the disk this way so that my 3D picture will make sense, right? Something like this. First of all, this little part is the small change in the x values, so it's still dx that we are talking about, so nothing tricky, okay? However, the radius is the part that's really tricky. Have a look. The radius is always going to be from the center to the end right here, but not all the way down here, right? Only from here to here. And now you have two y's that you are going to subtract. It's always going to be the top minus the bottom. And you might be wondering, why didn't I look at this? You don't look at that, right? Because originally the equation only works for the bottom portion, right? So this is the portion that you are looking for. This portion here is the bottom value of the y, the bottom function, which is y bottom, if you would like, and that's x squared, okay? And as you can see, this right here is actually y on the top. It's just equal to 1, so you have 1 minus that, y top minus y bottom. That will give you the radius. So now, we are ready. Let's go ahead and integrate it, and we are talking about in the x world, so let's go ahead and put down pi. And then this time, we will have to do top, which is 1, minus the bottom, which is x squared. This is the radius. And then square that, and then the dx. Because we're in dx, we should be looking at the x values, which is going from 0 to 1. Just like that. Okay? Now, don't worry, we have another one, so we can do another practice. Have a look here. This time, well, I will just try to draw this like this for you guys real quick. Okay, again, dx is what we are talking about, and we are looking for the radius from here to here. And again, for this one, the y on the top is 1, and then the y on the bottom is, well, this is what though? We need y to be in terms of x. So right here, I will just take the square roots on both sides, meaning I get y is equal to plus minus square root of x. But this is the positive square root part, so we don't look at the negative. So the bottom y is square root of x right here. Okay? So here we go. We minus integral, and pi is pi. 1 minus square root of x, and then square that because this is the radius. And then we have the dx, and we go from 0 to 1. And guess what? This is the setup for it. And of course, you do whatever you need to do to figure this out, but I will leave that to you guys. Alright, we're going to find the volume generated by rotating the region bounded by this and that, and we'll do it about y is equal to 1. Be really careful with this question, it's rather tricky, but we'll still do the fundamental. First, we draw a picture. 1 plus secant x. Secant x looks like this. We just have to shift up by 1 unit, right? And when x is equal to 0, secant 0 is 1 plus 1, and of course we end up with 2. So this right here is 2, and we have a picture looks like this, okay? It's like a U shape. And we just want one piece. We don't want to get like infinite amount of copies of the secant x. Next, y is equal to 3, which is above the 2, so I'll just do like this. So this right here is the region that we are talking about. And we're rotating about y is equal to 1, which is this right here. This is y is equal to 1, rotating about this right here. First of all, we may need to find out the x values. So here and here, how can we do that? Well, set these two equations equal to each other. So let's go ahead and do that. Right here, we have 1 plus secant x, and that's equal to 3. Minus 1 on both sides, so we get secant x equals 2. And if you don't like to solve equation for secant, you can change that to cosine. So this is 1 over cosine x, and that's equal to 2. Do the reciprocals, you know you're looking for cosine x is equal to 1/2. Where and where though? Well, have a look. Cosine is what? Adjacent over hypotenuse. So you can look at a triangle real quick. The adjacent is 1, the hypotenuse is 2, and you know this right here will be square root of 3. So this right here is going to be 60 degrees, namely pi over 3. Okay? So you know x is going to be, right here, it's going to be pi over 3. And we also need a negative version, which is negative pi over 3. And these are the two x values that we need, right? So not so bad. So let's go ahead and label that negative pi over 3 and also positive pi over 3, right? Now, this is the time we are going to do the rotation. So have a look here. Well, when x is pi over 3, if you put it here, secant is equal to what's 3, right? It's 3. So I will actually rotate. This much is 2, so I will actually rotate. And just get a big picture. I will first start with this right here. So here is my top curve, and I'm going to rotate it. And this right here is 2, this right here is 1, so we'll actually go below the x-axis. So it will go like this. Right? So it will be like this. Okay? And again, here is my x-axis. And here is where we are rotating about. So this is the center. Right? This is like the middle. This is y is equal to 1. Right? And then we are going to find the volume of this. So let's go ahead and do that first. Oh, by the way, I should also give you guys the y-axis. And then the second one is we are going to subtract the bottom portion of the curve, which is the secant x. And this is a 1 plus secant x like this, right? So take this portion, rotate it, and again, you are going to get below the x-axis. So try to make sense of this picture. On the top, it will look like this. Right, so this is the region like that. And then we will have some gap, and then mirror image like this. And it's like that. Right? So again, here is the x-axis, and here is y is equal to 1. Yeah, so you have a perfect cylinder minus the hole in the middle, like this. All right, enough talking, enough drawing, all that stuff. Volume is equal to the following. First thing first, this one, let's be fancy, let's use integral. Well, I will just do this right here. As we can see, we are using the disk method, and here is the middle, all right? All right, have a look. The thickness is dx, so that's pretty okay, because that's just a small change in the x values. the radius is from where to here? Well, I'm not going to draw from here to here because originally this is the function on the top. We have y is equal to 3 to begin with. So actually I have to draw it like this from here to be my radius. And the radius is precisely the top y value function, which is 3, and then minus the bottom y, which is 1. So of course that's equal to 2, right? So this is very nice, but I will just write this top 1 minus the bottom 1 for you guys, right? So just keep that in mind for that. So here we go. This is going to be the integral pi times 3 minus 1, right? The top y minus the bottom y, and then you square that, and then you dx that, and you go from negative pi over 3 to positive pi over 3. Phew, that's the first one. Not so bad. Now, have a look at the second one. We are going to subtract this one. Well, disk method again. Let me put a disk right here. Again, here is my center, and this right here is my radius. Hopefully you guys can see okay. And then, let me just do like this for you guys. And then, again, you refer back to the original picture. The top right here is the y equals 1 plus secant x. This right here, y on the top is 1 plus secant x, right? And then this y is actually the one on the bottom, so I will just put it as yb, which is just equal to 1. Again, always top minus bottom, so it's this minus that. That will be the radius. And of course, the thickness is still dx. So have a look. Integrating pi, this thing, which is 1 plus secant x, and then minus, right? Minus, maybe just make it minus in red, minus this. And then square that, dx that, and then we go from negative pi over 3 to pi over 3, like so. Very, very nice. And how are we going to do the integrals? Yes, I'm going to leave that to you guys. So you guys can comment down below your answer, and that will be very, very nice. But this right here is it. All right, we're going to find the volume generated by rotating a region bounded by this, this, and that. And we'll do it about x is equal to 2. So here we go. Let's have a picture. X to the third power, of course, is the cubic curve. So we have a picture look like this. This is y is equal to x to the third power. And y is equal to 0 is just the x-axis. And we want x is equal to 1. So we have the 1 right here, right? And keep in mind, when x is 1, y is also equal to 1. So this is the region that we want. And then we want to do this, right? We want to rotate this about x is equal to 2. So it's going to be right here. This is where x is equal to 2 is, right? So you're going to get like a volcano. It's like you take this part and rotate it, and here is how I will show you. First of all, this right here, it will be on the outside, right? So I will actually start with that. So I will do like this, and then I will come here. And again, imagine everything's filled in, right? That's the first part. So the top is going to be like this, and then the bottom will be like that. And this right here, right in the middle, is precisely x is equal to 2, okay? And here is my x-axis, and right here is my y-axis, right? So this right here is going to be the outer part. And then we have to minus the inner portion. Well, minus what? You pretty much just take this and rotate it, you get a perfect cylinder. So it's not so bad to do. So here we have this, and then rotate it like that, like that, like that, like this. And then again, well, this is meant to be when x is equal to 1. So my y-axis should be right here, right? So these are the pictures. And here is x equals 2. Okay, so maybe I don't want to do this. Now, integration time, of course. Here is the volume. For this one, pay close attention because it's tricky sometimes. First of all, we are using the disk method because we can just make horizontal cuts, right? And we can just draw a disk like so. Well, that's dy. Yes, just a small change in the y distance, so just dy. Good. Now, to find out the radius, you go from where we're rotating about to the curve. So we'll have to draw it this way from here to here. Okay, so this right here will be the picture for the radius. And we have to, how do we do that though? Well, here, notice that we have x. And in fact, this right here is the x on the right. And you always do right minus left, right? So for the radius, it's going to be 2 to begin with. And then here, well, we know that we have to get the x on the left. We don't have the x, because originally this right here is y equals x to a third power. It's okay, we can just take the cube root on both sides. So x is the same as the cube root of y. The x on the left, which is this, and that's going to be the cube root of y. So we just do 2 minus that, right? So here we go. We are integrating. Well, let's put on the pi. The radius is from here to here. And again, I draw it from here to here because we're going from here to here, right? Always refer back to the original because the equation is right here. So here we have 2. And then we are going to minus the cube root of y. And then don't forget to square that. And this right here, we are in the y world. So that means we have to pay attention to the y values. It goes from 0 to 1. Very nice. Right? Very nice. And just in case, sometimes if you don't know the y value, be sure you just check the x value. Maybe you just have to plug in the x value into the original so you can find out the y value. 1 to a third power is still 1, so that's pretty good. All right, for the second one, we are going to subtract. This right here, it's not so bad because it's a perfect cylinder, but we'll do it in the fancy way, integrals. So again, we'll draw a cylinder. Well, a small cylinder, which is the disk, like so, right? This right here is dy, very good. And then from here to here, it's going to be our radius. In fact, this again, of course, is the x on the right. So xr is equal to 2, the x on the right. And this portion here, this is just x is equal to 1, the x on the left, which is this right here, isn't it? Very nice, huh? So all we have to do is just 2 minus 1, of course. So anyway, pi is pi. For the radius is 2 minus 1, which is 1. But I want to just show you guys, we are consistent to do the right minus left thing, right? And then, of course, we square that, and then we dy that, and then we go from 0 to 1 that, and we are done. This right here is the integral for you guys. And of course, you will tell me the answer. Either you do it by hand, or do it on your graphing calculator. Depends on the direction. Anyway, that's it.